Now let's look at an application of linear inequalities. A company manufactures bookshelves and desks for computers. Let X represent the number of bookshelves manufactured daily and Y the number of desks manufactured daily. The company's profits are $25 per bookshelf and $55 per desk. Write the objective function that describes the company's total daily profit Z from X bookshelves and Y desk. What we're being asked to do here is to write an equation where we tell that the profit Z is going to be found in terms of how many bookshelves and how many desks we sell. Every time we sell a bookshelf, we make $25. So therefore, if we multiply 25 times the number of bookshelves, we'll find out the profit from selling bookshelves. In addition to that, we can make a profit by selling desks. We make $55 in this business by selling a desk, and each desk is represented by the value Y, or I'm sorry, the number of desks is represented by the value Y. So 55 per desk times the number of desks would give us 55Y. This is called the objective function, and we're going to use that in just a moment. The following problem is a continuation of our previous checkpoint. To maintain high quality, the company should not manufacture more than a total of 80 bookshelves and desks per day. Write an inequality that describes this constraint. Now, this is called a constraint because we are constrained, that is, held back, by the fact that we cannot manufacture more than a total of 80. In our previous checkpoint, we used X to stand for the number of bookshelves that were going to be produced, and we used Y to stand for the number of desks. We now are told that we should not have more than a total of 80. So if we take X and add Y to that, to have no more than a total of 80 means we have to have less than or equal to 80 for that sum. The following checkpoint is a continuation of the first two checkpoints in this section. To meet customer demand, the company must manufacture between 30 and 80 bookshelves per day inclusive. Furthermore, the company must manufacture at least 10 and no more than 30 desks per day. Write an inequality that describes each of these sentences. Then summarize what you have described about this company by writing the objective function for its profits and the three constraints. Well, here we're going to end up with two of our constraints. We know that from our previous work that X will stand for the number of bookshelves that we produce per day. Our first sentence tells us that that number, X, should lie between 30 and 80, inclusive. So we're going to write the inequality, 30 is less than or equal to X, is less than or equal to 80. The second sentence says, furthermore, the company must manufacture at least 10 and no more than 30 desks per day. The variable Y stood for the number of desks produced per day. Now we want to make sure that that value of Y is going to be greater than or equal to 10 and less than or equal to 30. We also had in our previous work the inequality that X plus Y had to be less than or equal to 80. And we had what we called our objective function for the profit. The profit was going to equal Z equals 25X plus 55Y. So this would be considered our objective function. And here would be the three constraints in relation to that objective function. Now we're going to complete the problem that we've been working on for the last three checkpoints. For this company, how many bookshelves and how many desks should be manufactured per day to obtain maximum profit? And then we'll determine what the maximum daily profit is. To complete the problem, we're going to start by graphing our constraints. Now, one thing to note is that since the number of bookshelves and the number of desks have to be positive numbers, we can concentrate on the first quadrant in order to graph this. So I'm just going to draw in a vertical axis and then go ahead and put the origin right here and draw in the horizontal axis. Now let's go ahead and mark off some units. We can see that our largest value is 80, so let's go ahead and use 10, 20, 30, 40, 50, 60, 70, 80. Do the same thing on the y-axis, 10, 20, 30, 40, 50, 60, 70, 80. And let's begin by graphing our constraints. We have here as our first constraint that our x value has to lie between 30 and 80. Now, to graph this, we can graph the border of x equals 30 as our vertical line going upward from the value of 30. We'll also draw another vertical line as a border at 80. Our first constraint says that x should lie between those two vertical lines. So we're going to draw this in, shading in between the two lines. Now let's move on to our second constraint. We're told that our y value is going to lie between 10 and 30. We'll graph the border y equals 10 as a horizontal line. Now let's graph the other border, y equals 30, as another horizontal line. And now we want our y value to lie between those two horizontal lines, so we'll shade in the region between them. Finally, we have the equation x plus y equals 80 as the border for our third region. So if we take x plus y equals 80, we can find our intercepts pretty quickly. If we let x equal 0, our y value has to equal 80. If we let y equal 0, our x value has to equal 80. Those are 2 points on the line. We'll draw this line in, the first quadrant. And then we can choose a test point in order to determine whether we should shade in above or below the line. Let's use the origin as our test point. If we substitute in 0 for x and 0 for y, we can see that 0 would have to be less than or equal to 80. The origin should be part of the half plane that we shade in, so we're going to shade in below that straight line. Now it's not nice to use different colors as you're doing this so you can keep track of your different inequalities, but at this point we need to find out the region where all of our inequalities are going to overlap. And I'm going to use the yellow pen in order to shade this in. We need to have the red, the green, and the blue in this picture. And the trapezoidal region that I'm shading in is going to be key to our finishing off the problem. To determine where we're going to get maximum profit, we're going to use the vertices of this trapezoid, and there are 4 of them. These are going to be the extreme values for this region. Let's now figure out the coordinates of each of these points. We notice that our first vertex is going to be 30 units over, 10 units up. So we have coordinates 30, 10. If we move upward, we see that we move 30 units over, and then we're up 30 units. So we have the point 30, 30. We have a vertex that is over on the line x plus y equals 80, but we notice that it's also on this horizontal line where our y value equals 10. And so if our y value equals 10, then in order to make this point on the line, we have to have 70 plus 10 equals 80. And then we have our fourth vertex. It lies on the horizontal line where we have our y value of 30. And again, also lies on the line x plus y equals 80. So to make that happen, we have to have 50 and 30. We're now going to take each of these points and we're going to substitute into our objective function. We'll determine where our maximum profit occurs by which of the points gives us the maximum value when we substitute in. So let's commence that now. If we substitute in the first point, 30, 10, will be evaluating 25 times 30 plus 55 times 10. That value is going to end up giving us a total of 1,300. Let's go to our next point, 30, 30. We'll be evaluating 25 times 30 plus 55 times 30. We can evaluate that and come up with a value of 2,400. We next go to 70, 10. We'd have 25 times 70 plus 55 times 10. That is going to give us a value of 2,900. And finally, 25 times 50 plus 55 times 30 is going to give us a value of 2,300. All we now need to do to answer the question is to notice that in order to get the maximum profit, we're going to have to be looking at this case. That was related to the point 70, 10, and we can interpret that by saying that we should manufacture 70 bookshelves and 10 desks for our maximum daily profit of $2,900. And now let's commence doing that substitution. Remember, our objective function was z equals 25x plus 55y. And here are the vertices that we want to work with. We're going to take each one and substitute as follows. Z equals, we'll have 25 times 30 plus 55 times 10. And to evaluate this, we come up with our total of 1,300. What about if we substitute 30, 30? We'll have 25 times 30 plus 55 times 30, and that is going to give us a total of 2,400. Let's go to our next vertex, 70, 10. We'll have 25 times 70 plus 55 times 10. That is going to give us a total of 2,300. And finally, let's have 25 times 50 plus 55 times 30, and that total is going to be 2,900. Now remember, our objective is to maximize the profit given by the value of z. We can see that the maximum profit will be $2,900 daily, and that's going to occur whenever we're using the values associated with the point 50, 30. That tells us to produce 50 bookshelves and 30 desks daily to meet that maximum profit.